Welcome to EduRev.
Hello children, welcome to EduRev classes. I am Sarvani Nandipati, your math educator. I have done my graduation from NIT Calicut and I have more than 3 years of teaching experience. In this video, we'll be continuing the real numbers topic. This is our second video. Our first video is about Euclid's division lemma. If you haven't watched that, watch that video also. So what is the second video is about? Fundamental theorem of arithmetic, and after that we'll solve few problems in it. Let's get started. So fundamental theorem of arithmetic. What does the theorem says? Every composite number can be expressed as product of primes, and this factorization is unique apart from the order in which the primes occur. So before understanding the theorem, let's try to know some terms. What is a composite number? A number which has more than 2 factors. And what is a prime number? A number which has exactly 2 factors. So what they are telling us is every composite number can be expressed as product of the primes, and after writing it as a product of the primes, the factorization that you are going to get is always unique. But you have to remember that the order in which the primes occur may differ, but the value or the factorization value will be always unique. Let's try to understand that with an example. Let's write the prime factorization for 240. I'm using factor tree method. If you find long division method easier, you can use that also, the continued division method. So 240, how can I write? Simply 2 into 120. 2 is a prime number, so I'm not disturbing that. 120. 120, how can I write? 2 into 60. And 60, 2 into 30. And 30, how will I write? 2 into 15. And 15, I'll write it as 3 into 5. So, if you're doing a factor tree method, one thing that you have to remember is one number will be prime number and the other number will be a composite or prime number. That is how you will be going throughout the factory tree process. So now what you got? 240 as simply 2 into 2 into 2 into 2 into 3 into 5. How can I write that as 2 to the power 4 into 3 into 5? So there are 4 2's, that's why I'm writing it as 2 to the power 4 into 3 into 5. So that is the prime factorization of 240. You may be thinking, ma'am started with 2, can I start with 5 and will I get a different prime factorization? Let's check that. So I'll divide it with 5 because the last digit is 0. So 5 table 48 times. So 48, what is 4 plus 8? 12. 12 is a number which is divisible by 3. So I'll divide it with 3. In 3 table it is 16 times. So 3 into 16, and 16 is divisible by 2 again. So I can write it as 2 into 8. And this 8 again I can write it as 2 into 4. And this 4, 2 into 2. So now what you are getting 240 as 5 into 3 into 2 into 2 into 2 into 2. And again there are 4 2's. So what will be the value? 5 into 3 into 2, 2 to the power 4. If you look at these two terms, see, here it is 2 power 4 into 3 into 5. Here it is 5 into 3 into 2 to the power 4. The order in which you got the values was different, but the value was same. That is what the theorem says. So any composite number that if you take and write it in the terms of product of primes, the factorization value that you are going to get will always be unique. I hope it is clear. I am moving on to the next slide. So where do we use this fundamental theorem of arithmetic or the prime factorization to find HCF and LCM of two numbers? HCF means highest common factor and LCM means least common multiple. So what is the process to find HCF and LCM of two or more numbers? First, what will we do is we'll write the prime factorization of all those numbers, and next we'll find the HCF. How will we find? After writing the prime factorization of all the numbers, you will see you will do the product of the smallest power of each common prime factor. So if you write the number 1 in its prime factorization and number 2 in its prime factorization, first of all you'll check which primes are common and after taking them, what you'll do is you look which prime number is having the smallest power, and that smallest power prime was taken and all those terms are multiplied. That will give me HCF. And how do I find LCM? Product of the greatest power of each prime factor involved in the number. That means the first number has 3 primes and the second number has 5 primes. So you'll check what is the you'll take all the different primes that are involved in that and write the greatest power of each of those prime factor. When I tell you in the theory part, you may be finding it a little bit confusing. I'll explain the same concept with an example so that you'll understand it better. And what is that? Find LCM and HCF of 24 and 20 and verify your result. So first write the prime factorization. 24 2 table 12 times and 12 2 table 6 times and 6 again 2 table 3 times. What is the prime factorization of 24? 2 into 2 into 2 into 3, that is 2 cube into 3. And now we'll write for 20. I can write as 2 into 10 and again 2 into 5. 5 is a prime number, so I need not go further. So the prime factorization of 20 will be 2 into 2 into 5. I can simply write it as 2 square into 5. So now your first step is done. You wrote the prime factorization for all the numbers. What is your second step? To find the HCF. How do you find the HCF? You'll do the multiplication of smallest power of each common prime factor. Look at these terms here. What are the prime factors? 2 and 3. And here it is 2 and 5. What is the common prime factor that is there? 2. Right. So you'll take 2. So it's 2 cube here and 2 square here. Which power I have to take? I have to take the smallest power. That means I have to take 2 square. If there was another number common, say here it is 3 square is also there here. So you'll take 3 and 3 square. Which is the smallest power? 3 is the smallest power. So you'll take simply 3 to the power 1 also and multiply that term. Here, as there is only one prime factor that is common, I am simply writing the smallest power of that as HCF. If there are two common prime factors, you have to write the smallest power of each prime factor and multiply them. So here the smallest power is 2 square among both. So 2 square, what will be that value? 4. So the HCF of 24 and 20 will be 4. And LCM of 24 and 20. How do you find that? LCM is nothing but the greatest power of each prime factor. So what are the all prime factors that are involved here? 2, 3 and 5. And you have to take the greatest power of all. Here 2 cube is there and here 2 square is there. Which is the greatest power? 2 cube. So you have to take 2 cube and 3 power 1 is there. Here no term is there. And that means I can simply take 3 to the power 0 because a to the power 0 is 1. So 3 to the power 0, 3 to the power 1. Which is bigger one? 3 to the power 1. So I have to take 3. And again here 5 to the power 0 is there because 5 to the power 0 is anyways 1. So, and here 5 to the power 1 is there. Which one I have to take? I have to take 5. So the value will be simply 2 cube into 3 into 5. See, the greatest power of these 2 cube and 2 square is 2 cube I have taken. And here there is no 3. So the largest power will be simply 3. And here there is no 5 term. So the largest power of both will be simply 5. So 2 cube into 3 into 5. What is 2 cube? 8. 8 into 3, 24. 24 into 5, 120. So the LCM of these two numbers 24 and 20 will be 120. So I hope it is clear how do we find HCF and LCM. Now we have to verify our result. So there is a condition. What is that? Product of two positive numbers, product of two positive integers should be equal to LCM into HCF. So what are the numbers? 24 into 20. That should be equal to HCF into LCM. That is 4 into 120. Let's check. 24 into 20. What will be that? 480. 4 into 120. That will also be 480. So your LHS is equal to RHS. That means the values that you have got for HCF and LCM are correct. One more thing you have to remember. this check is only valid for 2 numbers. If you take for 3 numbers, it is not valid. Product of 3 numbers will never be equal to LCM into HCF. I hope it is clear. I'm moving on to the next question. The two positive numbers a and b are written as a is equal to x power 6 y square and b is equal to x cube y power 5, where x and y are prime factors. Find HCF of a comma b and find LCM of a comma b. Instead of giving the numbers and asking us to do the prime factorization, they are telling that they have done the prime factorization and they are not revealing us the numbers, and they are telling that the numbers a and b are expressed in terms of product of prime factors x and y as shown here. They are asking us to find HCF and LCM. How do we find HCF of a comma b? HCF is nothing but the smallest power of each common factor you have to take and multiply them, right? So what is the smallest power here of what are the common factors? Both of them has x and y. Now each term you have to check the smallest power. For b it is x cube, for a it is x power 6. Which is the smaller one? X cube. So you have to take x cube, and now come to y. Y square and y power 5. Which is the smaller power? Y square is the smaller power. So you will take that and you have to multiply them. So it's x cube into y square, that can be simply written as x cube y square. Now what is our next task is to find LCM of a comma b. What is the LCM? It is nothing but you will take the larger power of each prime factor and write the product of them. So what is the larger power of x power 6 and x cube? X power 6. And what is the larger power of y square and y power 5? Y power 5. So what will be my LCM going to be? Simply x power 6 into y power 5. Or I can write it as x power 6 y power 5. So I hope it is clear. Whenever you are finding the HCF, you will take the smallest power of each common prime factor and multiply them. When you are finding the LCM, you will take the greatest power of each prime factor and multiply them. I hope it is clear, and I am moving on to the next slide. Consider the numbers 8 power n, where n is a natural number. Check whether there is any value of n for which 8 power n ends with the digit 0. So what they are telling us, there are a set of numbers which are in the form of 8 power n, where n represents natural numbers. And for any value of n you take, will the number that you are going to get will have the last digit as 0 or not? The question is clear, but how do you use the fundamental theorem of arithmetic here? Let's dig a little bit deeper. See, if the number is 8 power n and it should end with the last digit as 0, what is the condition? It should be divisible by 10. 10 is not a prime number, so write the prime factors of it, that is simply 2 and 5. That means if the last digit should be 0, it should be divisible by 5 and 2. If the number is divisible by 5 and 2, when you are writing its prime factorization, it should contain both 5 and 2. I am telling both 5 and 2. Both of them should be there. If one is there, you can't write it as divisible by 10. So now look at the prime factorization of 8 power n. How can I write that as 2 cube whole to the power n? Because 2 cube is simply 8. And it's in the form of a power m whole power n. That is a power mn. So this value will be simply 2 to the power 3n. So what is the prime factorization of 8 power n is having? Only 2, but there is no terms of 5. So I can clearly say that this number is not divisible by 10. Hence it will never have its last digit as 0. I hope it is clear. I am moving on to the next slide. In a racing competition, the time taken by two racing cars A and B to complete one round of the circular track is 1 hour 5 minutes and 45 minutes respectively. After how much time will the cars meet at the starting point? So what they are telling is there is a racing competition and two cars participated A and B, and the time taken by them was 1 hour 5 minutes for car A, and for B it is 45 minutes. And after they completed one round also, they are actually continuing the process. So after how long will they meet again? That was the question. So all the questions that you are going to see in the real numbers will be either based on the LCM or HCF. But you may be thinking, what should I take? Whether the LCM of these numbers or HCF of these numbers. Remember, think like this. If they are going in a circular track, the time they are going to take to meet again will be more than both these times, right? That means what should I take? I have to take LCM. So now you got the thing, right? Simply you have to find the LCM of these two things, these two times. But are these both times are in the same units? This is in hours and minutes, and this is in minutes. So your task is to convert both of them to the same metric. So time taken by A to complete race is 1 hour 5 minutes. 1 hour means it will have 60 minutes. 1 hour is 60 minutes plus 5 minutes. So A took 65 minutes. Always look at the units. They should be of same. And B 45 minutes. So your task is to find simply LCM of 65 and 45. Right? What will you do? You'll do the prime factorization for both. 65 I can write it as 5 into 13. And I can't factorize it further, so it's 5 into 13 simply. 45 I can write as 3 into 15, and 15 3 into 5. That is 45 is equal to 3 square into 5. The prime factorization of 45. Now you are supposed to find LCM. What will be the LCM of 65 and 45? Simply the product of greatest power of each prime factor. What are the prime factors involved? 5, 13 and 3. What is the greatest power of 3? 3 square. And what is the greatest power of 5 for both? Among both? 5. And what is the greatest power of 13? Simply 13. So it's 3 square into 5 into 13. What will be that value? Simply 9 into 65, that is 585. That means it will take 585 minutes for both of them to meet. It was too big number for minutes. Now you can convert them into hours. So to do that, I am writing it in this form using Euclid division lemma, that is 60 into 9 plus 45. 69 is 540 plus 45, that is 585. See, 160 minutes will be 1 hour. 960 minutes means it will be 9 hours. So this term tells us it is 9 hours and this term tells us it is 45 minutes. So how much time it will take for both of them to meet again? 9 hours 45 minutes. I hope it is clear. I am moving on to the next question. You are elected as SPL of your school and there are 56 students from 6th class, 42 students from 7th class and 21 students from 8th class. You have to arrange students in minimum rows in such a way that students in row belong to the same class. So again, they have told you how many students are there in each class, and they are telling you to arrange the students in minimum rows such that in that particular row the student should belong into the same class. Should I take LCM or HCF? If I take LCM, I'll get a number which is larger than all those three. That means if I take a small row, if I take a particular row, I'll get a number which is bigger than the student strength of a particular class. So it's not LCM. I have to take HCF. So this is the information they have given. 6th class 56 students, 7th class 42 students and 8th class 21 students. My task is to find the HCF of all these three. So what should I do first? I have to write the prime factorization. So what is the prime factorization of 56? 2 table 28 times, 2 table 14 times and 2 table again 7 times. So the prime factorization will be simply 2 cube into 7. For 42, it's 2 into 21 and 21 is simply 3 into 7. So all these are prime numbers. So the value will be simply 2 into 3 into 7. And what is the next one? 21. It's simply 3 into 7. Now you have to write the HCF. What will be the HCF? It's nothing but the smallest power of common factor. What is the common factor here? All of them has 7. Only these two has 3 and only these two has 2. So you should not consider 3 and 2. And what is the smallest power of 7 here? All of them has only 1. So the value will be simply 7 to the power 1, that is 7. So the HCF is 7. That means you have to arrange students in 7 rows such that all the students in a particular row will belong to the same class. We have discussed the problem based on LCM and HCF. So when they are given in the theory form or in the verbal form, the basic thing that you have to apply is the number that you are supposed to get. Should it be smaller than the given numbers or larger than the given numbers? If the number should be smaller than the given numbers, find HCF of them. If the number should be larger than the given numbers, find LCM of them. I hope it is clear. I'll end today's video session. So in this class, we have understood the concept of fundamental theorem of arithmetic and we have solved few problems on this concept. So in case if you want to look at the summary, you can check the notes section. If you want to practice more questions, you can do it in the HCF of Infinity platform. Or if you want to write the test, you can attempt and you will also get a national-wide ranking so that you can analyze yourself much more better and improve your performance. In case if you haven't taken the HCF Infinity subscription, do it today. Thanks for staying tuned. All the best.